Good evening, friends. This is Manish Khandelwal. I am a mechanical engineer, and the details of my experience are mentioned at the bottom of this slide. Today's presentation is on a very interesting topic, hydraulic system. Friends, in my whole career, I have found that the hydraulic system is used in most of the manufacturing facilities on one or the other machine. A motor is mounted on a sump filled with hydraulic oil. A fluid energy is generated by a pump, and this fluid energy goes into the actuator to do the mechanical work. The hydraulic system has generally a wide range of applications. They are capable of producing high power with high efficiency. So let's study some of the basic hydraulic structure. Friends, I have divided this presentation into 5 parts. One is Pascal law. Second is the basic hydraulic circuit. Third is functioning of important components of the system. Fourth shall be advantages and care required for the hydraulic system. And fifth shall be the popular application of hydraulic system. Friends, French scientist Blaise Pascal was the first person to demonstrate as to what hydraulic power can do. The world shall always be indebted to him, as he was the first person who gave the principle of hydraulic system. Pascal law says pressure change in a confined fluid is transmitted or distributed undiminished. That means without any loss throughout the fluid in all the direction. This law is applied only on incompressible fluids, that means the liquids. Let's see one example here. Let's see, this is a tube. So one side is having narrow cross-sectional area and the other side is having the larger cross-sectional area. When we are applying a force F1 here on the top, then as per the formula P1 is equal to F1 upon A1, a pressure P1 is applied here. Now as per the Pascal law, same P1 shall come here because the pressure is going to be undiminished. There will not be any loss. So if it is P1 here, it will be P1 here also. Now if you just see, what is P1? P1 is force upon area, F1 upon A1. And here, if force is F2 and area is A2, the pressure will be F2 upon A2. For convenience, let's say it is P2. But as we have just seen that Pascal says P1 is equal to P2. The pressure is same throughout the area. So that means F1 upon A1, this is the pressure, is equal to F2 upon A2. Now let us take one example. If I am applying a force of 100 newtons here, F1 is 100 newton. This is narrow, so I assume that A1 is 1 meter square. On the other side, this is broader size, so area may be twice. This is just an assumption. So A2 is 2. So what will happen here? Because F1 upon A1 is equal to F2 upon A2 as per Pascal law. So F2 will be F1 into A2 upon A1. Now F2 is, that means 100 into A2 is 2 upon 1. That means 200 Newton. What does it show? We applied a force of 100 Newton here. And if we are having a double cross-sectional area on the other side, then we will get a force of 200 Newton. If we double the area, we'll get double the force. And this principle is very much used for car lifting, for excavators, for many instruments or equipments. This particular law is used. We have seen that with Pascal law, the force is doubled if we double the area. Let us understand a basic hydraulic circuit. Here the hydraulic actuator is functioning. That means the system pressure is less than the set pressure in the pressure relief valve. That means if the set pressure in the pressure relief valve is P, then the system pressure is P minus. Some of the components in the hydraulic circuits: sump or the reservoir where the hydraulic fluid is put, suction strainer, electrical motor and hydraulic pump, discharge filter, pressure gauge, pressure relief valve, directional control valve, flow control valve, and the hydraulic actuator. So functioning of the hydraulic circuit is divided into three parts. So let's go one by one. The first part is shown in the dotted lines. Here the electrical motor is connected with the hydraulic pump, and this motor delivers mechanical energy to the hydraulic pump. The pump generates a vacuum at the inlet, which makes the fluid goes through strainer to the pump. The strainer removes some of the impurity from the fluid. Now the pump converts the mechanical energy received from the electrical motor to fluid energy through the fluid it has sucked from sump. And now this fluid energy is going into the system through discharge filter, which again removes some of the impurities. So that is first part. Second part of the circuit is having three valves. One is the pressure relief valve, second is the direction control valve, and third is the flow control valve. Pressure relief valve, it can be termed as the safety device and is available in all hydraulic circuits. The main function of pressure relief valve is to limit maximum pressure to a set value. That means if we have set 100 bars here, then the system will not be having more than 100 bars. The excess pressure, if pressure relief valve is not there, then it can damage the components in the system. It can burst the hydraulic pipeline, thereby the human being around may be harmed. The machines installed nearby can be damaged. These pressure relief valves are of two types. One is the direct acting type, second is pilot acting type. The selection of the valve can be done based on the usage. Here, of course, we have shown the direct acting valve. The pressure can be set by rotating this knob. You can notice there are two important components. One is the spring, second is the poppet. So till the set pressure, the poppet will block the discharge port. That means if we have set 100 bars here, so till 100 bars, this poppet will be blocking the discharge port and the fluid will be moving to the circuit. But if the pressure goes up, then the fluid will push this poppet down and will be released from this discharge port to the sump, thereby saving the further damage. Then we have the direction control valve. As the name suggests, the direction control valve in the hydraulic circuit controls the direction of the fluid flowing into it. The valve directs the pressurized fluid to the actuator we want. The valve can be manually operated or it can be automatic also. It has a multiple position which allows the fluid to flow into the direction we want. On certain condition, direction control valve bypass the actuators and sends the fluid directly to the sump. So if there is any problem where the actuator is not functioning, the pressure relief valve will pass the fluid, but direction control valve will act here and it will not allow the fluid to go to the actuator and it will rather send it to the sump. Then we have flow control valve. So in controlling we have three valves. One is controlling the pressure, another is controlling the direction, and third is controlling the flow. So this is second part of the circuit. Now finally, after passing through the valves, the fluid enters into the hydraulic actuator and it pushes the ram up and the hydraulic fluid escapes from the other end. The fluid energy here is converted into the mechanical energy which helps in doing the work like lifting the weight, etc. The reciprocating motion of the actuator is ensured by changing the direction of the fluid. This slide shows only the working of pressure relief valve. This is a direct acting pressure relief valve. The pressure can be set by rotating this knob. At the set pressure, the poppet of this valve blocks the discharge port of the valve. Now, if the system pressure or the hydraulic fluid pressure in the system is lesser than the set pressure, then it will pass through this valve and go to the system to do the rest. If the fluid pressure is more, then you can see it has pushed down the poppet and the discharge port is open. In this condition, the hydraulic fluid will pass through this discharge port and go to the sump. It will not go to the system further. You can see the difference between the position of the poppet here. One more thing, that if the set pressure is 100 bar, then the poppet will not go down at 100 bar only. It will start going down maybe at 90, 92 bar, slowly. And some fluid will be discharged maybe at 92, 95. So the pressure at which the fluid first discharge from the port, that pressure is known as the cracking pressure. So there is always a difference between cracking pressure and the set pressure, and the cracking pressure is always lesser than the set pressure. So let us know the working of directional control valve. So this is a 3-position 4-port direction control valve. These are the 4 ports, 1, 2, 3 and 4. The positions are marked with green color circle. These are the 3 positions. So let's study the 3 positions one by one. The oil is in the sump. In the first position, the oil will enter from this port and without doing anything, it is moving out. This is the position when we are not doing anything, our actuator is idling, but our machine is running. So it is not doing any mechanical work, only the oil is circulating from sump to direction control valve and return. So this is position number 1. Position number 2 is when the fluid is giving pressure to the actuator from bottom. So here what is happening? The fluid is entering here in this direction. This is the second position now. This is going and entering into the actuator from bottom. Now here the fluid energy is getting converted into the mechanical energy. It is lifting the ram or the piston up and doing the mechanical work. The piston, while going up, pushes the hydraulic oil out, which is shown with the dotted red line. So the fluid is entering in this position from here, going into the bottom, escaping from the top and returning again, showing into the dotted line, returning from here. So this is the second position where the fluid is making the piston go up. The third position is shown with the blue line. The fluid is entering here. It is going from here to the top, and then it is pushing the piston down. Now this is the reciprocating motion. It is pushing the piston down, and then this piston is sending the return oil back from this port, and it is going back, and all this oil is getting collected into the sump. I hope I have been able to clear the function of the directional control valve. The last slide is on overloading in the hydraulic circuit. So what is overloading in a hydraulic circuit? Overloading actually is a situation where the requirement of one or more component in the hydraulic circuit go beyond their capacity. The requirement for this cylinder is to lift 100 kgs, but its capacity is only 50 kgs. So the requirement has gone beyond the capacity of this cylinder. This is overloading. For example, a hydraulic cylinder is designed to lift 100 kgs of weight. But if we try to lift 200 kgs, then the cylinder may not be able to lift it. The cylinder in the process, if we try to lift 200 kgs, then the cylinder in the process may get damaged also. The other components in the circuit also may get damaged. So when a hydraulic system in overload condition works, the pressure in the system may cross the safe operating limits, and this can cause the damages to the components. This can adversely affect the performance of the components. Now, to avoid the overloading, what we can do? We can design the components being used very carefully, and the installation of these components have to be done very carefully. And one more thing, the proper and timely maintenance of the components is must. So what are the advantages and care required for the hydraulic circuit? First, the advantages. It converts smaller force to larger force. If we recall Pascal law, where a force applied on one end increases in proportion to the area on the other end. Second advantage is the hydraulic system has high accuracy. Again, the Pascal law says that the pressure applied to a fluid is transmitted equally in all the directions. So it has high accuracy. Then hydraulic system uses proportional valve also, which allows the accurate control of flow, pressure and other parameters. Then it can transmit high pressure and high torque. Friends, hydraulic systems have high power to weight ratio. That means as compared to their sizes, it generates a lot of force or torque. So this helps in doing the precise control. Then finally, durable and easily maintainable. It doesn't have gears or things like that, so it is easily maintainable also. Now, what are the cares which have to be taken? One is timely maintenance of components to avoid leakages. The maintenance of the valves, the actuators, very important. Otherwise, the gasket may cut and the leakages may occur. Then keep system free of dust to avoid oil contamination. If you recall our presentation on contamination, where we studied that contaminated oil, if passing through the valves or actuator, it can damage the actuator valves or it can cut the seals of the valves. So we have to avoid the dust first, and then of course the oil leakages also. Then maintain temperature of hydraulic oil. See, if the hydraulic oil temperature is more, then it will become less viscous, and again it is dangerous to the components in the circuit. Normally we have a radiator in the hydraulic power pack which helps in controlling the temperature. Then use appropriate and recommended hydraulic fluid only. The hydraulic fluid viscosity is normally recommended by the supplier, whether it is 68 or 32 Stokes. So they recommend some specification for the hydraulic fluid, and we should always use the recommended oil only. And finally, design the components in the circuit to avoid overheating. We have just studied that the bad design in the circuit may result into the overheating. So we have to design our components in such a way that we avoid overheating. So these are the applications of the hydraulic circuits. First is car lifting. This is a car. There are more than once we have referred this diagram. First in Pascal law. This is a narrow area. This is the larger area. Pressure is same. If force is applied here, then it will get converted into the higher force in proportion to the area. Then the hydraulic clutches in the automobile. Then the hydraulic presses. Here you put your job, and then this ramp comes down, presses, and gives you the desired results. Then these are the material handling equipment. This is the scissor table. Then we have a lot of hand pallet trucks and all, where the hydraulic cylinder, this is a hydraulic cylinder which is used. So once it is actuates, it moves the table up. Then the earth movers, a lot of earth movers uses these hydraulic systems, where this is a hydraulic cylinder. With the help of these cylinders we excavate wherever we want. So there are many other applications also of this hydraulic unit. So I would like to end my presentation here on this hydraulic system. But friends, this is a very basic on the hydraulic circuit I have informed you. The hydraulic circuits, hydraulic system is a very wide subject. So if you like the contents of this presentation, please subscribe my channel. Thank you very much.